Hi, everybody. My name's Chris Ayers, and today I'm going to be talking about how to get good with Advanced Git. So a little bit about me. I'm a DevOps lead, actually for the North American Azure and DevOps practice at New Signature. That's a Microsoft and GitHub partner. So I do a lot of DevOps assessments, Tfs Git migrations, Git training, doing pipelines and release automation, and a lot of counseling sometimes between siloed departments and organizations. Tooling is definitely part of the conversation, but when I'm dealing with organizations, usually it's the people and how they do their work through their process. You can reach out to me if you need something, and there's my Twitter and LinkedIn, and I occasionally blog, so you can find my website there. So today, I've only got maybe like 10 slides. So what I want to do is really have some terminals up, type some commands, and kind of dive into Git internals and how Git internally is structured and how it behaves. Little hint, it doesn't do diffs. There's no diffing going on. So it's not like SVN or TFS. We're going to go into rebase, reflog. We're going to do some resetting and then interactive rebase. So if you haven't done that, that's going to be pretty cool. So first off, the internals of Git. It's all hashes. Everything's a hash. Seriously, lots and lots and lots of hashes. so I will show you those. But conceptually, there's a couple of types of objects inside of Git. Most likely things are either trees or blobs. So if you think about a directory, that's a tree. So in this example here, the tree is going to say I have three things. I have a file, a blob called readme, a blob called rakefile, and another tree called lib. That's going to reference this tree, and it will say I have one entry, simple git rb, and that's a blob. If you take that a little bit step further, I mean, each thing has its own hash, and these are shortened hashes. Git uses SHA-1 hashes, but these are shortened hashes. So this tree is hashed, and you know that it's hashed because it's like, and I'll dig into it, but this file down here, this new file, it has its own hash, and in the tree, it will have that hash and the name, and we're going to see this in more depth. I just kind of want to show the trees have hashes, files have hashes, and those are pretty much the only two types of objects that you're really going to see in the Git tree. There are, of course, commits, but as far as the contents, things are hashed. So what happens if I change one of those files or I change that version? This is where those commits come in, and that those hashes are important, and we're not diffing things. So the Git database contains all of the objects that have ever been in Git. Like, it has that version 1 of the file, and it will hash it. So let's kind of walk through what this image is showing, and I'll kind of explain it. Yep, that's exactly what we're going to do with DevGuru. So on that first commit, let's say we have a directory that just has one file, test text. It's not hashing the name text. It's hashing the contents of that file. So version 1, the string version 1 inside of a file, has that hash of 83BAE. That one object, that version 1 content is hashed. Now, if we step back, there's a directory that has a file named test.txt, but it has that hash. And then that tree node is hashed. That's that first commit. If we change the contents of this test.txt to version 2, now we have a new tree structure. Notice we're not pointing down at version 1. We don't diff it. We now have an object in the database called version 2. And we have a new tree that has 2 objects. And we have a new file with a hash. Commit 3 is where things get really interesting. And I'm about to bring up a terminal, and we're going to play around with this. And so you'll have a little bit more context. On that third commit, let's say we have this back folder that has one file in it called text.txt with the version 1 string. We don't need to make a new folder to hold a thing that has one file with that content. It already exists in the tree. It already is in that database of objects. So instead of creating a whole new string or a whole new tree with one file and that content, this tree object just kind of repoints back to the old one that already exists. So as you start working and doing more work, there will be a lot of references between the different trees in the database, and it doesn't necessarily create diffs or new versions of things. This is almost like a giant deduplicated database, if you think about it that way. I think if when we bring up the console and we dive in, it'll be a little bit more context. But does this make a little bit of sense? I'm going to explain it more, but does this kind of show some of the differences between maybe an SVN type of, or a diffing type of system and a deduplicated hashed type of system? All right, well, let's actually dive in and see some stuff, and it will open your eyes to what I'm talking about here. So I've got two terminals, and I'm going to zoom this in a little bit. Zoom this in a little bit. Can you guys see that screen okay, or do I need to make it a little bit here? I'll make it a little bit bigger. Can you see that okay? All right. So, whoops. Empty directory. We're going to do a git init. So we now have an empty directory here. I have a script, and this is checked in. This is a tree command, so the Linux tree command of the Git folder. So when you do a git initialize, Git makes a bunch of these files and objects for you. And there's a bunch of stuff here under hooks. We can talk about that later. We don't really need them right now. Hooks are a whole different subject. So this is kind of what's hiding under the surface. No one ever really looks in the Git directory. You really probably shouldn't for the most part. But Git, the commands that most people know, Git clone, Git add, Git commit, Git remove. Git actually classifies those in a certain way. They call those porcelain commands. The ones I'm going to dive into a little bit today and show you in depth are called the plumbing commands. So if you go into a bathroom, you like to interact with the nice sink and the nice toilet. You don't want to go rip open the wall and get down into some crusty old pipe and dig with that. The Git API and the Git commands are kind of designed as an onion type of system. 80–90% of everything you need to do is done through those nice, pretty porcelain commands. Add, commit, remove, clone. Yeah, everything's great. You can actually like directly manipulate the database though if you go down a level, down into the plumbing, and it kind of shows you what's happening. So on the Linux, these are both running WSL, so I'm in Linux on Windows. So let's do high internet. I'm just echoing out a string. But let's put this into one of the Git plumbing commands called git hash object. Oh, nothing happened. I got it. Standard in. So I've given it this content of high internet. And this plumbing command is used throughout the system. You give it some content and it generates a SHA hash. And I've just told it to take that string from the standard in, and it's writing out to the screen. Now if I add an extra command and tell it to write it out, oh, things changed. So now we've actually written an object with the content high internet out to the Git database. And if you notice, this is the SHA-1 hash of my content. But over here, it takes the first 2 digits of your hash and it makes it into a folder. And then it puts the rest of it as a file underneath that. Well, all right, let's just cut that then, right? Super easy. Ooh, that's not what we want. Well, if we want to read it, we have to use a different command, cat file. So if I cat file and say p, and I give it that hash, yay, I get back my content. It prints out that content. Well, I can do -f and it can tell me what type of file that is. -t. It's a blob. So remember I said we had trees and we had blobs. So we've just taken some content, fed it into one of those plumbing commands, and it is written it right to the database. All right, cool. Let's see our status. Well, we haven't committed anything. So all we've done so far is we've added a file right to the database. Okay, well, that's still not a commit, so we need to do that git add thing, but let's not use git add. Let's use something else. Let's use update index. So the index is kind of our what's the status of our current working directory. We're gonna add, we're gonna tell it the permissions of that file, and we're gonna use that hash of our content, of our object. And what name should this file be? Let's say it's hi.txt. Oh, notice it says that, yeah, I'm using oh my bash or oh my posh type stuff, so it shows you what branch you're on and the status. You can see it seems like it's dirty. I check my git status. It thinks my working directory that I've created a new file, but it also says I've deleted a file. It's very confused. And if I look, there's no files in my Git directory. And there's just an object over there, but we haven't really done anything. So the git status is one of those nice porcelain commands. What if there's a command under it that just accesses the index and tells us what the index thinks should exist in our current working directory? And we still haven't committed. We still haven't created any tree objects. All we've done is told the index that there should be a file named text or high text, which is why it thinks there's a green new file. But when you look at the actual directory, there is no file, so it thinks it's deleted. So it's a little confused. So let's write out our tree. So this is going to take our current working tree and write it to the Git database. Ah, now something else is happening. Let's take a look at this guy. So we do that git cat file again. Wonder what type this is. There's that tree we were talking about. Well, what's inside that tree? So there's the permissions. It's a blob, and that is the hash of the content of the current directory, and it should be with that file name. So if we go back real quick to this slide, those trees and hashes make a little bit more sense now, right? So the tree is that hash that we were just looking at, and it lists that there's a file named this with that content. So are we good so far? All right. So we've written our tree to the disk, but we get status, still no commit. If I do a git log, nothing. So let's do a commit. Let's commit it out. So we're going to commit tree. We're going to use that hash of that tree. I'm going to give it that message. Oh, did I grab the wrong thing? Well, I should have grabbed the right thing. Let's see here. Problems occur. Let's try that. Grab the wrong hash. Too many hashes. You have some sharp-eyed people in the chat window. Thank you very much. So let's just kind of look at where we are right now. Git status. We still have a weird state. Let's do a git log. It says master doesn't have any branches. It's kind of weird. Let's also look at this new hash real quick. I slide the divider to the right more. Is that better? All right, so let's do that cat file again. What is in that? That is the wrong one. That's the one. So that was our commit, and we can see that the tree we had was that tree object from above that we passed. It has my information from my git log, and it has my message. So that object here, this 3b, is in the database as a commit, but things are still acting a little bit funny. So let's actually look inside Git. What is head pointing to? So head is pointing to refs head master. Well, we don't have a refs head master. So we need to tell it that master is pointing at our new commit that we just did, this 3b one. So there's a command, there's another plumbing command to do that. So we can do an update ref. We're going to say, hey, refs.head master is going to point at that commit. So now you can see refs head master points to there. There's a link in logs. So if I do that git status now, it's kind of happy, but it says I deleted something. And if I looked at my git log, okay, git log is working. My head is pointed at master. So things are a little bit better. Well, what's going on? We never actually made a file. We just took content and put it right into the database and manipulated the Git database. So I can now just do a git checkout for master, and I want to get that high text file. Now we're green. And we're clearing on master. So I know that was a lot, and we really went in depth. I see somebody is saying where I would need to use cat file or cat TS. So there are instances where people maybe try to mess around in their Git directory, which you shouldn't, or something gets corrupted. If you're curious what an object is, you can go in and construct it. So I'm going to just stop that real quick. So I could do that git cat file, print it out, and well, I didn't mean to copy that whole thing. So I just wanted to try to make sure that people understood the relationship between commits and trees and objects. So do we have a new respect for some of the things that are hiding deep inside the Git database? All right. All right, so now let's actually look at merging. Oh, yep, there was that demo. Okay, we're gonna talk about merging. And I have a link here, and I'm actually gonna go ahead and paste that in the chat. I came across this a while ago. This site is amazing, absolutely amazing. This is the site. So you can like play around with stuff. And so I'm gonna do free explore. And see there's a little box at the bottom left. And here, let me try to make it bigger. So I can do just something like git commit, and it adds a node. I can say git branch feature, and it makes a feature branch. And I can say git checkout feature, and now I'm on feature. So I can kind of play around. Git commit, and I can hit up. So I can add a few. I can add a few commits. So this might be the workflow that a lot of people have. You know, they start with master, they make a branch, they do their work, and now they want to merge it back. And if I git merge feature, what happens is this is what they call a fast forward merge. There's no differences between the current node of master and the first node of feature. There's no changes. And so what will happen with the fast forward merge is if you put all the nodes together, it will just move master right there. That's called a fast forward merge. Yeah, the tree underneath a commit is a complete copy of, no, it's not diff based. So I'll make sure the slides get posted. I see the question about, is the tree underneath commit a complete copy? A tree is, each commit is the tree, which is the current directory, and a listing of all the files and the hashes of their content. So if I renamed a file here, and here, actually, let me go do that. I will do that right now. So if I look here, got the tree loop again. I got a file. If I, let's see here. So we don't have a cajillion new objects, but we do have some new objects. And if we look at them, let's see here. Git cat file, print. So that one's high internet. I'm pretty sure I know 3B. So that was my new commit, and that points at this tree. So if I look at that tree, so that still says high text, but it has a different blob that we had before. So the old high text still exists in the database. The old tree that had high text with a different blob hash is still in the tree. This is essentially a completely deduplicated copy of every object that's ever existed in Git. This is why putting binary files that change often inside of Git is usually bad, and your database will grow to gigabytes very quickly if you're sitting there editing, like, you know, PSD files and PNG files. It can be painful. So just trying to address that. So back to this. So
hey, Chris, quick question, unless you just answered it. Quick question in chat if you glance over there.
yeah, so the parent only exists to the commit object. Yes. So looking at this commit object, there's that parent. If I look at this, that's the previous commit. If I look at the type of this, that should be a commit. And if I look at the printout of it, you can see it's a different tree. And then because this was the first commit, the first one I did, there's no parent. So now we've established that tree or that descendant line and where branches and all that come from. Does that answer your question? All right, well, let me get back to this. So this tool is great for visualizing what happens. So we just saw I forked off of master, and let me refresh it and do it over again. I'm going to reiterate things. I'm going to answer questions. I want to make sure people have good understandings of this, because most of us use these tools every day. And so having a little bit better understanding of our tools will definitely be helpful. So we got to commit. We're going to do a branch feature. We're going to switch to our feature branch. We're going to add some commits. So what happens if I'm on master and I do a commit there, and now I want to merge in feature? So what happens is Git looks and says, oh, this is not the closest descendant to that. There's a difference. So it will back up to here and do like a merge. So let's look at what happens when we merge in feature now. So it makes a merge commit. And personally, I hate these, because this is not I actually did content. This is just combining stuff. I am a huge fan of rebasing if you do it every day. Like the reason I hate merges personally is seeing, well, historically I've seen many people try to do git flow, and git flow to me just introduces merge hell. I'm a very big proponent of trunk-based development. I'm on master, I branch, I do my work, I merge it back in, and I've got a pipeline that's compiling it and testing it and deploying it, and I don't want to have a build per branch, or I want one set of binaries that goes everywhere. So this dashed line is that merge commit from head down the feature. So I don't like doing that. So let me show you what a rebase does and what a rebase is, just so that we can see that. So, you know, again, got my commit, got my feature. I might go to feature, I'll do my commits. Yep. Now I'm going to check out master. Let's do another commit. Let's go back to feature. So I want to be on my feature branch when I do this. So Git Rebase, what it tries to do is it tries to rip off. It goes back to that first descendant here, and it wants to kind of unhook these and then try to replay them on top of master, so that you have a very consistent history. It kind of tries to get rid of merging. And so when I do this, if you pay attention, you should see it unhooks those and tries to replay them on top of master, and then it gets rid of them. This is not atomic. So like there can be a lot of individual things, but you can see this had one hash. This is a completely different hash because its parent is different. So the commit is different. So the hash on that commit is different. So the hashes do get changed when you rebase. But conceptually, you know, this is, I think, much cleaner than merging. It looks like a straight line of history with your work, rather than these like coming together with these extra nodes of merging. So let's actually play around with that a little bit. I've got another little tool.
Can I ask a question?
Yeah, please.
So I guess I never understood rebase enough, because in the past I've done it like on a branch that would be a shared branch, and it's, you know, one of those things. Yeah. So seeing that clarifies that I should be doing it in the branch I'm working in.
Well, so there's another thing. This is all, yeah, you're correct. We're going to get in the ref log, Kathleen, in just a minute. And that's where I'm actually about to go to. Yes, you can orphan code. And, but one of the things that's very important is Git is a distributed database. There's a full copy up in the cloud. There's a full copy locally. If you don't push your changes up, if it's just locally and you've done some commits and you've done some things that you want to try to fix, you can fix them. You can do some crazy things, and you can really rewrite history. You can delete check-ins, merge, and we're going to touch on that locally. If you have pushed it, you're kind of stuck with what's been pushed. And that's where you might run into some issues, unless you have force push powers, and I highly recommend not doing that. It will really mess with your fellow coworkers sometimes if you've done a force push and rewriting the universe, and then they kind of try to keep working. And yeah, come on, Kathleen, you're just taunting people now. Stop force pushing. Yes, with lease, I know, but all right. So we've got some commits. Great. So this is just a log. All it's doing is doing a log. You know, I can, I have a little tool. I'll just make 5 files. So I've got some text files here. And you can see I'm still on master while I'm doing this. So I'm going to make a branch. Just like we did before. I'm going to check it out. Keep trying to do features. I don't know why. Actually, let's do. If I look at my current directory, that it's like that. I'll just go in the files. I'll do the same thing again. Pathing. So we got some more files in my feature branch. So that's what we're looking at right now on my feature branch. So why don't we merge that? There we go. And you can see it fast forwarded, nice and clean, no problems. Okay. Well, what if I don't want to do that? There's another commit, or what if I want to see what's happening, what's going on with the past? Maybe I didn't want to do that merge. So if I look at a little command called reflog, and reflog right now, like this is worth the price of admission right now. So reflog, if you look here, so there's head at 0. This is where we are right now. We've done a fast forward merge from master. Head at 2, we were doing some commits. There's that checkout for master to feature. Let's say we go back to that, head at 7. So if I do a git reset hard and head at, it's back before we checked in some stuff. Like some interesting things have happened. Like it doesn't even really know about the other branch. You know, maybe I screwed that up. Maybe I didn't go to where I wanted to go for that one. Maybe I want to go back. So I'm moving from feature to master. So reflog can let you manipulate a lot of things. I think I wanted to be here. I want to be at head at 3. Reflog lets you screw around with a lot of things. So now I'm at head at 3. So I'd already merged. All right, that's not where I wanted to be. Maybe it was head at 4. So I think I screwed something up, which is fine. Let's go to 5. So you can see this one only has 4. So it was replaying some of those things. Reflog will show you a lot of the state of stuff, and yeah, you can really mess things up if you're not careful. There we go. That was closer to where I wanted to be. Commit, 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 commit. Well, whatever.
Quick question in chat, Chris.
Yeah. Oh, I'm sorry.
Yeah, no, it just came
Yeah,
up.
so ref log, in layman's terms, is a log of some of the references of head. So as you've manipulated stuff, as you've checked out different branches, as you've done different commits, it keeps track of that position you are, the position of where that head is pointing. So looking at this, there's tons of data tons of objects now in that, and you can see there's 2 links, but head is where our current working directory is pointing. So when I look at my current working directory and I do a tree of it, and I've merged in, those 4 files, and when I look at git log, this is that commit we're talking about right now. So I'm on this commit where I've added this file, and and actually fun story, there's another tool called git parse. So anything that I can pass in, like head or head at 4 or master, anything that's identifiable get, rev parse will spit out the GUID or the SHA hash of it. This can be used with, if you're concerned about where reflog is going to take you, you can kind of look at some of that and you can try to figure out, oh, is it head? Is it this one? What is that full hash that I'm going to be moving to? So reflog is that history of hashes of where your working directory state has been. So I'm actually just going to reset it back down here to I think it looks like I've done this a couple of times, reset to this directory, but let's reset it back to the beginning. Before I added all those files. So if I look at git log, it's just the one I've modified. If I look at my tree, all those objects still exist in the database. Even though I don't have the commits anymore, the contents has still been added to the database. So if I might have some cruft left over in there. Yes, essentially it's a list of the hashes that's been the hash of the current directory I'm in. So let's do this again. Like I said, I think I I got a little off the beaten path because I wanted to look at some of the merging that we're going to do. So let's make feature branch again. Nope. Check out feature. Let's see where we're at. So feature has all those files. Okay, and let's look at the tree because we had added those files to feature. All right, so let's check out master. So it still has the histories there. Let's look at the state of master. So it has some of those files. What happens if we try to merge them? Well, I've made 2 sets of files with the same name because I regenerated them. So when I do the merge, it's going to say I have conflicts. So the automatic merge has failed, and you can see I'm in a weird state. So they both added that. Has anyone run into this problem before where you've edited a file and someone else has edited a file at the same time? And you both tried to kind of merge on different branches. So if we open up file 1 here, because they were both added, this is showing you, hey, I had some content and they had other content, and I have to resolve this in order to continue with my merge. A lot of times this is handled by your editors. So if you load this in an editor, many times they will handle the merging for you, or at least the visual display of stuff. Actually, having a bad day today. There's a lot of tools that can help with it, but let's just go ahead and fix this real quick. Let's say I want to take my version, and I gotta pretty much edit all of these. quick. Still both added, so I've resolved them, but I need to now resolve the merge conflicts, and I let it know that I finished those by adding those to my commit. I was ready to be commit.
Quick question in the chat for you, Chris.
Yep. Yes, typically you would want to, like in this particular case, it's garbage. It's just random text strings, and you can see there's this merging happening going on. A lot of times when you're doing a merge, the systems will tell you. So if you have a nice CI/CD pipeline that's set up on a pull request to run, it can check, will the code compile? But if you've edited something and they've edited something and you're trying to make some logic changes, it might not do what you expected it to do anymore. So I typically do work with the other person to sit down and go, hey, you added this or that. But if it's something really basic, they just, you know, that you can read and make sense of yourself, then I might not, but I'll usually ping them and say, we both edited this, I'm doing a merge. But this is on your branch a lot of times. In this particular case, it was on master because I did some stuff. But notice we now have that merge commit, and all it is resolving the differences between these two. Merge commits are, eh. So let's look at that ref log again. So we did the merge commit. There's another syntax for looking at the previous commit. So we've been doing this at head thing. Well, what if we do head here? So our current one is head, which is 597, which is right here. That's where we are. But if we do head that, it's EB9, which is here. This is where we were on master before. That little dot right there. That's the same thing as in our ref log example. Let me go find ref log real quick. Should be head at 1. Yeah, head at 1. So there's a couple of different syntaxes. So head at 1 is that. So that caret syntax, and if I want to look at the one previous, so 188, if I do that one here. So let's look at what that one is, 3D4. Actually, that's just taking us back in time on the commit. So it's following the current chain backwards. So the first head was that, the second one was that. If I do it a third time, we'll see 496. 496. So let's undo this. Like I said, let's reset things again. Let's go back one. So we haven't done the merge yet. So let's go to our branch. And let's rebase onto master. Let's see what that looks like. So we still have that merge conflict because we edited both files. And so what's happening is it is just like this example here, where it pulled those nodes off. It's trying to replay this one, this first one, or one of the ones. And it's one where master's already edited the file and I'm trying to change the content. So it's not going to be the exact same commit as I had before. It's creating an all new set of commits, but it will look like I just took the latest copy of master and I went in and made my edits. And when we're done with this rebase, it should have one nice little straight line. So if I do my Git status, you can see it's now just me kind of editing file 1. So okay, I can look at file 1. All right, so let's do that. I know rebases are scary a lot. So now it's green again. So if I look at my status, it's green, and we can continue the rebase. And you can see it's in the middle of the rebase, and I need to do my rebase continue. Like, keep putting those nodes back on. So it's going to stop again. And if I look, that commit was fine. So let's continue the rebase again. We had already resolved it. So I told it to skip it. I'd already done it twice. So now look, it's saying file 2. So if I do git status, file 2 needs to be edited. So this one's a little bit more complex because I have 5 files I had issues with. And when you use GUI tools, they can be a lot more user-friendly. But I always feel when I train people, I want them to learn a little bit through the command line to kind of understand a little bit what's happening. So we already did the git add. We already did the commit. So we can skip. So now it's going to keep going. So now we're on to 3. I know, fun times. This is so exciting. Can I skip without editing? It will check in. So if I don't, let me do this. So now we're up to 4 now. So I can just add it, but and you can see this is the automatic merger. So you can see the patch that failed. This was, I tried to make a new file from null, and doing a diff, it sees I was trying to add that content in. If I edit this file, because I do want to show you what happens if you just add it without editing. So if I edit this file, and just to look at what content's in there, there's this little syntax here, which is the git diff syntax. Rebase is more than just changing the head. It is that whole popping off and replaying stuff on it. But if I just tell it, hey, add 4, and keep moving on, you know, I can do that merge. That hey, I made a change. Yeah. Yeah, we're green again. Let's continue the rebase. Keep going. It's gone up to 5. Okay, so let's look at what. Don't worry. We're gonna get to that in a second, Kathleen. If we look at 4, 4 still has that crazy merge syntax. If we look at 3, where I'd edited it, it's still nice and clean. So we're now on 5. So I can clean that stuff up. I can go and clean up 4 again if I want on this time. And I can add them both in, saying, hey, I made these changes, and I commit those changes. Merged. Not my favorite thing to do in the world. So let's continue that rebase, and then finally we should be done. That was a really complex one, and you can see it's all reapplied. Let's look at what that history looks like. So these were our 2 merge commits when it was trying to reapply our new messages on top of from feature onto master. So it's kind of realigned them. And one of the very important things about rebase is I'm doing it from my feature branch. And what this is doing is this is getting my feature branch ready to merge into master. Notice master's still back here, but now it's not a tree where they've diverged and they have to get merged back together. It looks like I took master and I just made some commits and I'm good to go. So now if I go back to master and then I merge in feature, it's just a nice straight line. It doesn't have These were those couple of commits I did because I intentionally did commits. If I hadn't intentionally done the commits, I would have had just this nice straight line of add 1, 2, 3, 5, 4, 5, add 1, 2, 3, 4, 5. Now, that's not the nicest. There's another thing you can do. Let's look at the ref log. And Drew, how are we doing for time? I don't want to get too far over.
The time slot is it's a 2-hour time slot. So
okay.
Plenty of time. I mean, how much?
No, I'm good. I usually do about an hour and a half, so I was just making sure.
Yep.
So let's go back to, what was I gonna do? Sorry, I lost my train of thought. Let's go back to head 10. Let's try an interactive rebase. So master's nice and clean again. And features back to where we were. What if we want to do an interactive rebase? So the interactive rebase, let's say we want to do an interactive one back to here. So EB. Notice this just brought up, I'm not a fan of cherry picking. That one, we'll talk about cherry picking in a minute. So interactive rebase. This can be a great way to kind of combine and merge and clean up some of your commits. So looking at some of these commands, you can see that one's on the bottom. That's the oldest. And in this particular case, it's at the top here. So the top entries are the oldest, and it goes kind of reverse chronological order, with the newest ones being at the bottom. And right now it's saying pick, 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 pick. So looking at the commands, and the documentation is pretty good on this. So pick means we're just going to put the command in right like it was. Reword, we can actually rewrite our commit messages, or maybe we want to squash them. So let's just squash all of these. See what that looks like. And so we have to pick one, but the ones after it will all be squashed up into that previous one. And we could do something different if we want. If maybe we didn't even want, maybe we don't even want 4. We can do that. Or maybe we don't want 2. Let's do that. So this is VI, so I'm just going to go ahead and save this. And it's doing the rebase. So it's taking those commits and it's doing stuff. But now it's saying, this is a combination of 6 commits. I need to give it the new commit message. So I'm going to clean this up some. So added file. Notice that 2's not in here. 1, 3. You can be a jerk. You can just do the interactive rebase and dump the old message, but please don't. So we now just have one message with all of those commits that we've squashed down. And if we look in that files directory, 2 isn't there. We actually just removed one of the commits and we squashed the other ones down into one thing. If we go back, and merge in feature, it'll just fast forward and it's much cleaner.
quick change of topic, Chris.
Yeah.
Let's see. It looks like a question more about checking out a subdirectory, like with a sparse
Yeah.
checkout kind of
So
thing.
most of the commands, let's say I remove, you can tell I like to live dangerously with the RF. I'm just like, hey, do it. Most of the commands allow you to do minus minus, and you can specify something after that, and it's like only check out that stuff. So let me look at my status again. Everything's green. Let me get rid of files again, and let me edit one of the files. New content. Check my status. You can see I've modified a file and I deleted a bunch. So if you want to reset one file, like if you've jacked something and you just want to throw away your changes on that, or you want to undo something, like I said, you can do that minus, and I could specify just one file, and it'll check out or whatever that one file. I can do a directory, and it's left my modified content alone because I didn't tell it to go reset and nuke my whole tree from orbit. I told it to just go and recheck out that one file or that one set of files. Is that helpful? Now, like someone did say, well, here, let's actually go and check some stuff out up here. So again, all of this is great when you're working locally. As soon as you start involving a remote branch, that's when crazy things happen. And something else, let me just touch on it real quick. So when you're in Git, I always do that. So I don't have any remotes right now. You can have multiple remotes. You know, if you fork let's say you fork a repo, for instance. I have a couple of scripts here. Let me fork this. Well, no. I've got one I think I have forked. Yeah, no, I have one. So I use different tools. Github Desktop has a nice little GUI. You know, I'm using a command line tool here to look at stuff, but there's also like for some people they like GUIs. Git Kraken has a free one. Source Tree has one. Source Tree is through Atlassian, so they do a lot of Bitbucket stuff. So you can see that this has the nice little GUIs. There you can see the branches and if you have a lot of history and path, it'll show it. I've been using this quite a bit, the GitHub Desktop. So I've been playing with this because you can easily go to the Explorer or Visual Studio Code or open a terminal. So I'm gonna just open a terminal into something I've branched off of the .NET architecture page, just to show something real quick with masters and remotes. If it opens, I did just update my terminal today, and I did just reset all of my settings. So that's probably a great way to break demos, is to do something right before a demo. So I've heard. Okay, so it's in there. Something's not happy right now. Yeah, something's very not happy right now. So that's my origin. This is their repo. I know why. I didn't fork it. So I have a number of repositories. Some of them I have forked. So let me look at this one. I apologize for the delay. So this one, you can see it's been forked. I'll just copy that. Clone it. Clone it there. All right. So I just want to talk about, oh, that's Oh My Posh. That's the same as Oh My Bash and Oh My Z Shell. So Oh My Posh and those all add these things. So it'll tell you what branch you're on, if you're ahead of master, modified files, things like that. It does use, these are called Powerline type extensions, and they have it for, they have a number of themes and colors so that you can style it however you want. They're very nice, and again, there's an Oh My Z Shell and an Oh My Bash. I'm using also the Windows Terminal, and the Windows Terminal comes with a font called, oh, my brain just went blank. It's a really nice font too. What is the font name? Cascadia Code. And they added in, they have the font right out on GitHub, and they added in the Powerline fonts. So if you don't want to download code, or you're not a fan of the Windows Terminal, you can still come out here and get the font. And they have a monospace one with all the little extra Powerline stuff to make the terminals look great. I did Oh My Bash on the Linux side for my Ubuntu WSL because I like it. So yeah, you can do it wherever. Anyways, back to where I was trying to go. Git remote -v. So that just has mine. But when I look at GitHub and I look at that repository, I forked it from here. So let me look at my forks. There's mine. And I can see the fork right here. I might want to get changes from the upstream. So I can actually set my remotes. So I could do a get remote command, and right now I just have origin, and you can do -h. You can see, so I could add, remote. I can set URL, and the name might be upstream, and I might put that URL. I gotta add it. Long day, people, I'm sorry. So now if I look at my remotes, you can see I have an origin and an upstream. So I could do a get pull origin or upstream into master. And so this is taking the changes from the source repository that I forked a while ago, and is pulling those changes down into my branch. And now my local branch is a couple ahead. If I look at git log, I've got some, this is equal to upstream master, but it's not equal to my origin master. So there's a difference between, I have that fork that's the master one, and then I have my local one. So if you ever fork a repository from somebody, and you're working in your local copy and they're working in their copy, and you want to get their updates, make sure you have their remote added so that you can pull down their changes. And then now that I've pulled them down, I've pulled down that master branch into my master branch, I can push it up and now this is in my branch. And if I look at my commits, there's been a couple of commits that are more recent than I had before. So that's just something real quick. And if I look at my status, I'm all green and everything. So you branch the master, you fetch the origin, then you check out master. Oh, git pull upstream. Yeah. Ah, okay. So someone has was the recommended work for clean branch from a remote upstream master. A lot of times I'm just on master and I do my work, and then I'll rebase onto it as best I can and submit a difference between a fork and a clone. Yeah, clone just takes a copy of the existing database, and you're still pointing all your stuff up at it. The fork kind of changes the base URL. They're very similar, but a lot of times, yeah, they're very, very similar. It's kind of where we have a new database and they start to diverge. Yeah, something like yes, fork is a server side thing. So back to where I was. I'm sorry, there's a big diversion. So I wanted to talk quickly about reverts and resets. So we were doing the rebasing, and we were doing reflog, and we did some resets, we did some interactive. I just want to talk about reverts real quick. So reverts, so let's say we're on, we've got our master merge and we've got our feature. If I do a git revert and I say that, I don't know if that'll work here. All right, that doesn't seem to work in this. It's not very nice. Let's go back down to this one then. Get our live log. So if I say git revert, like most of the git commands, there is a little bit of documentation on it, but let's just go ahead, say which one I want to revert. So let's say I want to go back to where I put this in, reverting that. This commit reverts that. So it doesn't delete the commit. It doesn't reset it like head does, or like the reset does when you do hard, and just move the pointers around and actually remove commits. What a revert will do is it will kind of make a new commit that's the opposite of the previous commit, or a series of previous commits. So I really hate when I see them all over the place. Tons and tons of reverts. And I've seen this in some organizations where they feel like maybe instead of trying to fix a problem, they'll try to back out code and do a hot fix like 5 versions ago. And so they'll do revert. Let's make a hot fix. Okay, now replay all your changes back on top of it. Unrevert. Has anyone ever seen that? Never. So I'm not a huge fan of it. I mean, there are use cases for it. Again, if you've already pushed everything up, that might be your only option in some ways, or branching off of a previous. So, you know, we can do that. You check out 3D454. Notice I'm only doing some of the hashes. That's that same as we did that rev parse. So anything like at least about 4 characters. And then revision, so let me try 7 DDC. So if you can do enough of it, like I said, at least 4. If there's not enough variety, you'll get that error. But are the reverted files still in the staging area? So master. So this is where we were. We were at our revert they are not still in the staging area. They're gone. We reverted them. We got rid of them. But they are in the database still. We're just, our current version master is not pointing at it. So that's back to all that database and tree and parent stuff that we talked about before. And with that, any other questions or anything you guys want to talk about? I know I kind of got on a tangent towards the end with some of the stuff talking about the remotes, but this has been a good conversation and some great questions. And it sounds like we got some people with some great experience in the chat room that have been able to help with some of their answers. Kathleen, thank you. So any other questions or things you guys want to talk about or chat about? The problem I was originally trying to solve when I dug into this is, yeah, I do a lot of TFS to get conversions. So I do migrations of TFS servers or SVN. We'll bring them into Git. There are toolings that can help replay checkouts one at a time and yeah, there's tooling. It can be nasty, but after that gets done, I find a lot of developers are very confused about Git, and then they start learning the basics. They know how to clone, they know how to add, they know how to commit, but they don't understand what's happening with some of the rebasing. They don't understand some of the more advanced commands. And you see, most of the time I've been living in the command line. As long as you're on your machine and you've done some commits, you can rewrite history, you can fix mistakes. It doesn't have to be super scary. But I've dealt with a lot of people that don't want to kind of get their hands dirty with command line. They just want to live in the GUI. To get buy-in on migrating to Git from SVN. Yeah. I've used Git TFS. I'll give you guys another little fun thing I've done. So up in GitHub, I do have a couple of repositories, and one of them, I do a lot of Azure Devops work, and so one of the repos I have here is automating Azure DevOps. And so I was doing some work through, this was 6 months ago at this point. Yeah, I was doing a migration from TFS to Git. So I had some client I was migrating, and they had a project name, and I built up. This was around the time the Azure CLI came out, but we're taking this DevOps collection and we're moving it into Git, and so I generate a hash, and I do the Tfs Git Clone, which takes that TFS with all of the history of check-ins, and it moves it into a Git repo, and I generated a Git ignore. And these 3 lines are your friend if you've never used them before, and I'll go ahead and put them into the chat. What that does, and let me see if I can quickly show you. So let me, actually, let me just free the current folder. So let's just say I don't want to check in high, and I want to use a Git ignore. Git ignore is great. There's a ton of resources for using them. If you go out to GitHub and you look up like Git ignore anything, like Python, there is a repo out there, gitignore.io, and you can grab one. They have a operating systems, IDEs, whatever, and you can combine them. You can combine multiple, and you can create one, and it'll put together like, hey, ignore all my VS Code. Sorry, ignore all my VS Code. Ignore the builds. Like I love this. They also provide, and you can actually see it. So they also provide some functions to help you do that. So I have a PowerShell function that does a a call out to git ignore IO, and this is up on GitHub, and with the languages you want to do a git ignore, and it adds it to that repo, which is pretty cool. I create a new repository out on Azure Devops, and this actually creates the first commit using a git ignore file from Visual Studio. You can do that. So using these scripts, which anybody can grab, yeah, clone a repo. This resets your files. So going back to that example I was about to do, I've added a git ignore. And if I do a git status, I can add it. I can commit it. If I look at my status, oh, whatever. If I look at my status and I look at my my git log, I added it, but nothing happened to high, which is what I wanted to ignore. So if I take these 3 lines here, which are pretty nice, what it does is it gets rid of everything from the current working directory and re-adds them back, and then kind of commits it. And all it does is, if you've changed your git commit file, this will remove the things that should have been removed, like you had it from day one. So if you had a bunch of binary files checked into your repo, if you had a bunch of crap, and you update your git ignore to remove those, yeah, of course it's not going to show that because I'm in a weird place. Git's gonna like not track high anymore. So if I edit high, yeah, it's gonna stop tracking it. Yeah, this is probably still gonna stay. Yeah, nothing to commit, working tree clean. But if I edit like the file 1, it knows I modified that. So I had a bunch of files and I wanted to add one to be ignored, so that those 3 lines are your friend. Remove cached, so I just kind of flushes my local directory, re-add the ones that are important, and everything that should be gone will be the difference. So that one's fun. Yeah, and back to this. Yeah, this makes that new repo, clones over TFS, creates a sample YAML file, adds it, creates new build pipeline, pushes it all up, creates a build definition, starts it, and applies build policies. So you can automate a lot of your Git creation and project creations. But yeah, those 3 lines are fun. And mean about it, and doesn't know you and doesn't want to listen. Counseling. When you are, so when I talk about DevOps a lot, there's 3 things that usually come up. And I do a number of presentations on just DevOps. So like, here's one. So if you want to define DevOps, it's not just a job title, it's not just automation, and it's not just small releases, and it's not just dev and ops looking at each other from across the lunchroom, whatever that may be. It really is people and process and product. So yes, Git might be one of our tools that we use, but you have to work with people, and they have to there needs to be psychological safety at your work. There needs to be collaboration, communication. Yeah, if someone's a jerk, you got to try to talk to them. And if that doesn't work, you got to kind of elevate that conversation however you need to.
I think one of the questions was also of any online resources to dig any deep.
Yeah, so going back to here, there's a Git book that they give out. The entire Git Pro book is published here, available online. And guess what? I just put the link in the chat. This has a lot of stuff. And if you come down here to Git internals, this is where some of the ideas come from for like the plumbing and the porcelain and diving into this and how they describe it. They have links to Git tools. They talk about hooks and attributes and some of the tooling. There's a lot of great tools out there. Atlassian, I'm not the biggest fan of some of their tooling, but honestly, their Git lessons are pretty rock solid. They're pretty good. So they have some how it works and then learning Git. And so here's some basics on collaborating, like syncing. And what's nice about some of theirs, they have some really nice diagrams of and commands that go with it. I refer people to this stuff all the time. Yeah, using branches, little feature, big feature. Submodules, I don't use them a lot. I know that I've used them for some things. I use multi-repos. I'm not a big fan of mono repos that are like 5 different projects in one that are all released independently. I usually like 5 different repos. For sub-projects, it depends. Like if I'm doing a library, I would rather not check out the source code to the library and build it. I would rather check out an artifact that has been tested and certified and I know it's versioned and I'm using that version instead of pulling in a submodule with that code. And I don't know if someone's changed it since the last time I built things and now my app is blowing up. So Git submodules, what the question is about. And it's right in here. Like your subfolder is like a whole nother Git repo, essentially. So when you check out a project with, like if I check out this main project, DB connector might be a whole different, a whole different repo. And so you have to use some extra commands like submodule init and submodule checkout. Yeah, I think it's very confusing to some people of the repo, and I'm not a fan, like I said, because if I had a versioned copy of DB connector like 1.1, I knew what the state of it was. I knew what my dependency was. If I was just pulling their code in and they changed it, I would not know what the state is at any one time. So that's my 2 cents on it. Any other questions? This has been great. Oh, Brian's got his hand up. Oh, that's applause. Thank you, sir.
Fair enough.
All right, let me stop sharing my screen then. There we go.